Hello everyone, welcome to my YouTube channel. If you are preparing for software developer interviews, there are three parts of an interview loop. The first part is the coding interview, the second part is the system design interview, and the third part is the behavior interview. I have made videos about how to ace your system design interviews in the past. In this video, I'm going to give you different tips and techniques that you should use to ace your coding interview. I will also solve a coding problem in this video while giving you all the tips that you should follow in order to pass your interview. In order to be successful in your coding interview, you need to understand what are the different things that an interviewer is actually trying to evaluate the candidate for, to consider that candidate for the job. We will start with the very first point. The first thing that the interviewer is trying to evaluate a candidate for is the requirement collection. The interviewer likes to understand how well the candidate can actually collect all the different requirements for the problem. Sometimes the interviewer gives you a very vague problem, and then the interviewer tries to see how the candidate can actually clarify all the requirements by asking the right set of questions. Other times, the candidate actually can give you a very clearly defined problem, but then the interviewer is evaluating the candidate whether the candidate can identify different edge cases in the problem. So the very first thing that you have to do is that when an interviewer asks you the question, during the first 5 to 10 minutes, I would say preferably 5 minutes, but if not 5, then I would say at most 10 minutes, you should be able to clarify the problem itself. You should be able to identify different edge cases in the problem, and you should be able to come up with different test cases that you will use to evaluate your code. So again, the very first thing, during the first 5 to 10 minutes, preferably 5 minutes, but if not, at most in 10 minutes, you should actually clarify the whole problem. You should be able to identify different test cases or edge cases in the problem, and these are basically your test inputs that you will use to test your code. Then the second thing that you need to understand that most of the time candidates actually just try to actually discuss the problem and try to understand it, but they do not try to follow a test-driven approach. And that's very important. You should always try to follow a test-driven approach, and this is now connected with the first point, where you actually, once you clarify the problem, you also come up with different test cases or edge scenarios or edge cases, and that you will actually inform the interviewer that these are the different test cases that you will use to test your code. Now the third thing that you need to understand is that usually the type of questions that are asked in an interview, they usually do not require writing a lot of code. Mostly, I would say almost 85 to 90% of the problems require writing you a very minimal amount of code, usually 5 to 10 lines at most. So now in your coding interview, if an interviewer has asked you a coding question where you have to write a lot of code, it seems there's something wrong in it. Either you haven't figured out the problem correctly, or you may have not come up with the right solution for that problem. Here also, I do like to mention that there are some problems still, like 5 to 10% of the problems that would require writing a lot of code, but basically you can avoid writing a lot of code by actually dividing your code into different functions or modules. So what you need to do is actually you have to use a modular approach of writing code, where you will break your code into different functions, and maybe you may not have to implement all the functions. You will implement only certain main functions, and maybe some other functions you will not even you will just say the interviewer that let's assume that this function does something like this. And this is very important because when an interviewer asks you such a question where you have to write a lot of code, basically this is one other thing that the interviewer is evaluating you for, which is basically that how good you are in writing modular code. In the past, when people most of the time used to write code on a whiteboard, what they used to do in the coding interview is that they first used to write a detailed pseudocode or algorithm, and once they have written it, then they actually convert it into a programming language of their choice. I would not recommend it now anymore. I would say if you even have to discuss the algorithm or pseudocode, just discuss it at a very high level, basically that's what you are going to do, and then just start write the code immediately, I would say, because usually now in a 45-minute interview you don't have much time. Most of the time the interviewer is expecting you to actually solve the problem within, I would say, 20 minutes, so that he can ask you a follow-up question. And that is why it's very important that you should always try to minimize the time that you need to spend to solve the problem. Now most of the time you will find that a problem can be solved in multiple ways. So it's better that in the first 5 to 10 minutes, once you have clarified the requirement, in the next 5 to 10 minutes, you should actually discuss at least 2 approaches to solve the problem. And then after discussing at least 2 different ways to solve the problem, you should also discuss the different pros and cons of these approaches. And then based on that, you should identify which approach is better, and then have confirmation from the interviewer that okay, that you are going to use that approach to solve the problem. And that's where is the point where you should start writing the code. So now if we break down the time spent on each thing, so the first 5 to 10 minutes, what you would do is basically you will actually clarify the problem and come up with some test cases or edge scenarios for the problem. Now the second 5 to 10 minutes, you will actually come up with a solution, and it is better always to come up with at least 2 different approaches, not just one. Discuss 2 different approaches and then discuss the pros and cons of those 2 approaches, and then identify which approach is better. And then usually after that, when you have to write the code, it shouldn't take more than 5 to 10 minutes. As I said, most of the problems, almost 80 to 90% of the problems, they would require writing less than 10 lines of code actually. Now, one final thing I would like to also mention you is that whatever programming language you are using, it's totally possible that the interviewer may not know about that language. For example, when I was interviewing a few years ago for my current job, I actually write the code in C++, but one of the interviewer didn't know about C++. But what I was doing, that when I was writing the code, I was actually explaining every line of code that I was writing. And that's why it was very easy for him to grasp what I'm doing. And I'm talking about few years ago, like 4 years ago before COVID, where we used to write code on a whiteboard like this. And so this is very important. Like when you are actually writing your code, you should think out loud. Whatever you are writing, you should also say it out loud. Usually when the interviewer is evaluating you, it's not just evaluating you whether how good you are in your coding or problem skills. The interviewer is also evaluating you whether you are good in your communication skills or not, whether you can easily explain different concepts or not. That's why it is very important that you always think out loud and you always try to explain whatever you are writing in the code to the interviewer. Nowadays, most interviews are now happening online, so that's why I will actually go with that format now in order to solve the coding question. Now consider this problem. This is problem number 199 in Leetcode, which is binary tree right side view. So given the root of a binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. Suppose this is a binary tree, which is actually, you are actually looking at this binary tree from the right side. So if you are looking at this binary tree from the right side, the nodes that you will see would be the node number 1, node number 3, because node number 2 would be hiding behind node number 3, and then you will see node number 4, because the node number 5 would be hiding behind the node number 4. So what you are supposed to do is to write a function which actually returns you a list of nodes which you will see. So for this example tree, the output would be node 1, 3 and 4. Now the main thing is that here what you should do is that now you should identify different test cases or edge cases, I would say, that you should actually discuss with the interviewer. So the very first test case would be, what if you have given an empty tree? So this is what you need to discuss with the interviewer, that whether an empty tree is a valid input or not. If it's a valid input, then of course what would be the valid output would be of course an empty list. But if it's an invalid input, then you need to throw exception. And that is a very important thing which most candidates actually are unable to identify, is that if an input is invalid, the code is supposed to throw exception or return error value. So let's suppose you discuss with the interviewer and the interviewer said if the tree is empty, you should just simply return an empty list. So what is the first input or test case? It is empty tree. Now what would be a second test case? The second test case would be a tree with just a single node. Let's suppose a tree with single node 1. Now what would be another test case? It would be a tree with, let's say, 2 nodes. One is the root node and then maybe one child. Then the fourth one would be 1, and now the child is not the right child but the left child. Now the fifth test case would be 1, 2 and 3. And of course here now the output here is 1. Here the output is 1 comma 2. Here the output is 1 comma 2. And here the output is 1 comma 3. Now let's see some advanced test cases as well. So the sixth one would be, let's say 1, 2, 3, and now this tree has a right child. Of course here the output would be 1, 3 and 4. And if you want, you can also come up with another test case which will be a bigger tree, something like 1, 2, 3, 4, 5, 6, 7, 8, let's say this guy has 9, 10, 11. So that is your first step, that what you would do, you will come up with different test cases and you will understand, okay, what would be the output in these cases. For example, here the output would be 1, 3, 7, 11 and then 12. Now the second thing is how to actually figure out what is the best way to solve this coding problem. You have to find the list of nodes that you can see from the right side. So in order to find the list of nodes, you have to traverse the tree. And now what are the different ways to traverse a tree? There are 4 different ways to traverse a tree. One is pre-order, then the second way is in order, the third way is post order, and the fourth way is level order. So what is a pre-order? In pre-order, you first visit the root node and then you visit the children of the node. Between the children, we first traverse the left child and then we traverse the right child. What is in order? In order, you first traverse the left child, then you traverse the root node, and then you traverse the right child. What is post order? In the post order, you first traverse the children, left, right, and then you traverse the parent. And what is a level order traversal? In the level order traversal, you traverse the tree level by level. So first you traverse root number 1, then you traverse the second level, so 2 and 3. Then you will traverse the third level, which is 4, 5, 6, 7. Then you traverse the fourth level, which is 8, 9, 10, 11. And then you traverse the next level. So now if you think about this problem, there are 2 different ways to solve this problem. The first way, which seems very obvious, is basically when you are doing the level order traversal, you will actually in every level consider that last node as the node which you will be seeing from the right. For example, here this one is the last and the only node, so this node is the node that you will be actually looking from the right side. Now in the second level, when you traverse in the level order traversal, like you go to 2 and then 3 is the last node, and since 3 is the last node, then of course then you will put 3 in your result as well, because 3 is the other node that you can see from when you're looking at from the right side. In the third level, when you traverse, you will traverse this node 4 first, then node 5, then node 6, and then node 7. And since node 7 is the last node, so you will actually put this in your result. So we are going to solve it with the level order traversal. Then we will see the second approach, how you can actually solve this problem. So in order to traverse a tree in a level order traversal, you need to understand that you should always use a queue. First of all, what we would do, of course, we will actually always validate the input. So let's say if root is equal to null. So here I would like to mention one thing, that I'm using Java here. So this is actually, you should always discuss with the interviewer that which programming language you would like to use in your coding interview. So let's suppose we have already discussed with the interviewer that if the root is null, it's a valid input, and in this case maybe you should return an empty list. So return collections dot empty list. Of course, now what you would do is that you will actually now define a queue. So let's say you define a queue of tree node. Let's give it a name queue is equal to, let's say, new. The second thing is that you should also now define a sentinel node that you should also insert after inserting all the nodes in one level. to identify that okay, now this level has ended, or now you have traversed this level completely. So let's define a sentinel node, final 3 node, sentinel, new 3 node. And of course, now since you want to return result as a list of integers, so you should define that as well. So list of integer result new array list. Now of course, what we would do is that you will actually add your root node in the queue. So queue dot add your root node, and then the second thing is that you will also add the sentinel node in the queue. So you are doing that because whenever you encounter the sentinel node, you can actually say that okay, now the previous node is the one which is the last node in that level, so I should put that node in the queue. So of course, for this, what does it mean? That you also need to define a previous node as well. So let's define a previous node as 3 node previous. Let's set it to null right now. So while queue dot size is not equal to 0, okay, so while the queue is not empty, basically what you are going to do is that you will remove a node from the queue. So let's give it a name, node equal to queue dot remove. If node is not equal to sentinel node, okay, if this node is not equal to sentinel node, what you will do, that you will set the previous equal to this node. The other thing that you should always do also is that you should also put the left and right child of this node into the tree if they are not null. So if node dot left is not equal to null, then you should put queue dot add node dot left, and then you do the same thing for the right child. If node dot right child is not equal to null, you should put queue dot node dot right child. So you should put right child in the queue. This is very important, the order here, because you are traversing from left to right. That's why once you encounter root node 1, you will first put the left child and then the right child. That's very important. Now the thing is else. So else here means basically that now the node is equal to sentinel node. It means this node is equal to sentinel. So it's a last node. So in that case, whatever is the previous node, you should put the previous node in result. So result dot add previous. And then the very important thing is that let's suppose the input tree has just a single node. So what you did here, if you see, you put this node here and then you put the sentinel node. Now when you pop, now so it means in the queue there are 2 different nodes exist. So once you pop the node 1, okay, and then what you did actually, you try to see whether it has left or right child, and say if they doesn't have left and right child, you won't do anything. Then you will pop the second one, and this one is the sentinel, so you will come here. Now this is important thing. Now if the queue is empty, you don't want to do anything, you just want to break the loop, okay. Otherwise, if the queue is not empty, if they are still like let's say in this example where we have on the left side where you have put 2 and 3, then you, of course, what you want to do, you want to put a sentinel node after this 3. So in that case, what happens that if queue dot size is not equal to 0, what would you do? You will do queue dot add and you will put the sentinel node in it again. And this is the whole code would look like, and then of course you will actually return the result. Now if you, let's suppose, run this, what happened? Oh sorry, this is tree node, and I think there's one other thing that I missed, which is really here, it shouldn't be previous, it should previous dot value. So this is accepted, let's submit it, and you see this is now accepted. However, now if you look at this code, it is around like 10, 15, 12 line of code basically at most. It's on the high side, and usually most of the time the interviewer will accept this, but now the interviewer will ask you 2 things. what is the computational complexity of this code and what is the space complexity of this code. So as far as the computational complexity, it is O of n, because you have to traverse all the nodes of the tree. And what about the space complexity? So in that case, let's take this example here. First you will put in the queue 1, and then you put a sentinel node. Then what would you do when you pop this? You will put 2 and 3, 2 and 3, and then since it's already popped, and then you find this x, you will put this x here. Now in the next case, what would you do? In the third level, you will take the children of 2, which is 4 and 5, you will put them, and then you already pop it. Now you pop 3 and then put the children of 3, so you will put 6 and 7. So what you are actually doing here is, if you see what is happening, is that you are actually at level here, let's say level 0. You will only put one node in it. At level 1, you will put 2 nodes in the queue. At level 3, you can actually put at most 4 nodes basically. So if h is the height of the tree, then the space complexity is O of 2 to the power h. So this solution we just solved right now using level order traversal, but this is not enough, because if you think about it, what you actually have to do is that you have to traverse a tree, and first time when you encounter a node, basically, especially if it's the rightmost node in one level, you should put that in the result. So I think we can actually solve this question very easily using a pre-order traversal, where whenever you traverse a node, you just have to make sure that if you are traversing that node at that level first time, then you should insert it in the result. And then in that case, when you are traversing the children of a node, you just have to make sure that you always traverse the right child before the left child. So now let's try to solve this question using a pre-order traversal. Is that I'm just going to comment out this code. Let's keep this part as it is. Now let's define the result now, and the result is basically a list of integer result equal to new of array list. Now what we are going to do is actually we are going to define a private function that this function will call for pre-order traversal of the tree. So let's define a function as private void pre-order traversal. We will pass tree node root. We will also pass a level, and then we will also pass list of integer and the result itself. Now the main thing is that if the root node pass is null, you just simply return, you don't do anything. Now the second thing is that if this is the first time you are actually traversing this level, so in that case there won't be any entry present in the result array at that level. So this is you can easily check using if result dot size is equal to basically the level itself. So let's say we will see this now. What does it mean? You will actually add the result dot add root dot value in it, and then what you will do, you will call the same function again, and first you will make sure that you call this function with the right child, because you want to see the view from the right side, and then level is actually increased by 1, and you pass the result as it is, and of course then you do the same thing with the left child. And now if you call this function here, you will just call it with the root with the value of level as 0, because this is the first time you are calling it. And this is now a pre-order traversal. Of course, this solution is a recursive solution, and you can always implement this in non-recursive way using a stack. Now let's submit the code. So this is accepted now. Now again the question is, what's the time complexity or computational complexity, and what is the space complexity of this algorithm? So first of all, the time complexity is On because you have to traverse all the nodes of this tree. However, the space complexity is less. At most, what you would do basically is that you will actually store at most number of nodes equal to the height of the tree. So here the space complexity is O of h instead of O of 2 to the power h. Now the last thing to consider is that there are always some follow-up questions that an interviewer can ask you. For example, the interviewer can ask you what would happen if instead of from the right side, you look at a tree from the left side. How you will tweak your solution in that case. Let me know in the comment below, what do you think, what we have to do in that case if the interviewer asks you that you are not looking at the tree from the right side, but instead you are looking at a tree from the left side. Apart from that, there are other follow-up questions that the interviewer can ask. For example, what if you look at a tree from the top? Similarly, an interviewer can also ask you, what if you look at a tree from the bottom? So let me know in the comments below that how do you think we can solve these questions, and if you want me to make videos on their solution as well. And in the end, I will really appreciate that if you find this video useful, then please do like a video and also do add a comment. And if you haven't subscribed to this channel yet, then please do subscribe, and do let me know whether you like this coding video or not, and do you want me to make more such videos or not. Thank you and take care.